Hello, guys. Welcome to another episode of the Stupid CS Guy. In this episode, I have invited a software engineer to come and design a system like Uber Eats, Doordash, or Swiggy. Now, this is a really large system to design and very difficult also, and we'll talk about it more in a little while. Also, the video is pretty large. I have linked to the interesting bits where I give feedback in the description. Go check out that. Without much ado, let's start with the interview. Okay, I have started recording. So the interview question for
Awesome.
today would be uh, design a food delivery app. And a couple of things about the food delivery app is the restaurant order management system. Each restaurants have their own order management system. You can assume something there, like the restaurants, each of them have some of the proprietary system, some
Mhm.
of the shelf software that they use for their own order management system. Uh, your job is to show the menu to the user, take the orders, relate to the restaurant, and show the status and get it delivered to the user.
Okay. Show menu to the user. Uh, get the order and place. Send that request to the restaurant. Am I audible properly?
Yeah, yeah, absolutely.
Okay. So yeah, this is one thing, and then should we also track the order status?
Yeah, drop the order status. Yes.
Okay, and ensure, so tracking we can ensure that the order is delivered to the customer.
Yeah,
Now, who takes
with
care of the delivery? Is it like I
yeah,
take
that
care
would
of
be
it?
the food delivery app itself. So there would be a delivery arm.
Okay. I need to take care of it. Okay. What else? What else? So I need to take care of it. Delivery, order status. Uh, Okay. What kind of so the thing is that when I'm delivering, it will be from completely from the, let's say, Zomato, right? Zomato is delivering. Let's say
Yeah,
we are trying to design Zomato. So
yeah.
like in Zomato, we track it from our system itself. The maps are shown that the delivery person is ours, the Zomato's rather. So here the delivery will be done um, by the restaurant, or the fulfillment has to be done from the app side,
The
or
fulfillment
from
has to be
restaurant
done
itself.
from the app. So let's say you'll have to take care of the
Okay,
fulfillment bit of it.
sure. Delivery plus full.
So what you don't need to
Fine.
take care of it is the order management part of it. Like you don't have to think about thus whether the item is in stock and whatnot. You can just relay the order and they will say
Correct.
that.
So the only thing that we need is, because if each one of them has got their own OMS, so we also need integration.
Some sort of integration, yeah.
Their OMS. Okay. So yeah, this will be the sixth requirement. Not in order, but yeah, some sort of requirement. Okay. Let's see. So restaurant. So a user comes into my app, searches for a food or something. So I need to prepare. So let me think about what needs to be done. So I need to have a catalog of of dishes per restaurant,
Mm.
so that this would actually serve me the menu to the user. Uh, yeah, I need understanding of some sort of understanding of the restaurant's location. Location of the restaurant. Third is a location plus working hours, maybe.
Yeah, you could make it
Okay.
simpler. Say that when the restaurant starts, the rest you have something where the restaurant tells you that the restaurant has started. So
Fine. That we can definitely do. This could be like fixed or
yeah,
say
yeah, it's
some
fixed.
eventing system,
Yeah, I mean whatever is simple is fine.
right? So eventing system probably will, that integration with the OMS would
Yeah,
take care of. Maybe. I mean, I'm just thinking out loud,
yeah.
not yet concrete. So we'll think about.
So you can see how John is listing down the requirements. He's not only just asking questions, he's also coming up with his own features, saying that hey, this might be required, that might be required, and also look for the terms that he's using. If somebody asks you to design an e-commerce app, these are some of the terms that you would be using a lot, like OMS, which is an order management system, fulfillment, which means so who is the person delivering the order, and then you have the state machine. What he really means by state machine is that you have two life cycles that needs to be tracked, and that is what makes the entire problem very challenging. You have the order life cycle, so your orders created, order cancelled, order in progress, and all of those life cycles. And after that life cycle is complete, you have the delivery life cycle that starts. The delivery person has a delivery get created, and then from there the delivery is in progress, and the delivery is completed, or delivery could not be completed. So these sort of life cycles are what he is essentially meaning when he says, state machines.
To go to that particular restaurant, and the delivery boy goes to the restaurant. He says that okay, he is in the restaurant. Then the food gets prepared. So there are two state machines that is going on, right? One is kind of on the restaurant side where the food is getting prepared, and
Yeah,
then the delivery system that is in sync with that preparation, right?
correct,
So
correct.
once the
Yes.
food is ready, at that point of time, the delivery boy picks up. So basically, maybe when from OMS system, when we get event saying that okay, the food is ready, we can send the delivery boy a notification saying that okay, pick up this food,
Yeah,
and then the boy says okay, I have picked up, and then he we start tracking his movement changes or something like that, right?
I
Maybe
see.
the
Yeah,
handheld device could send us GPS locations of him, and we
yeah,
could trace that over a map,
yeah, yeah,
right?
yeah, yeah.
And show it to the customer,
Yeah,
something
we,
like
we
okay.
can we can simplify it there. Like for now, we can say that some of the delivery people are mapped to particular pin codes. Like you don't have to go
Okay,
looking
okay.
for the closest one, just to reduce complexity. We'll just say that
Mhm.
there, there's some metadata which maps delivery guys to particular pin codes.
Okay, fine. So assumptions. So number one is delivery boys per pin code is fixed.
Yeah,
Need to only take care of busy versus free, right? This
yeah.
I'll have to take care.
Or if they're
I cannot.
if they're working, like they could be
Yeah, yeah, yeah.
not working.
If working, right? Uh, okay. Then let's consider. Um, okay, this is the assumption. And do I have to take care of like how far the the I mean the geofencing sort of like kind of like if I'm in this location, at what is the area which I'll cover for the restaurant for showing it to the person, right?
Yeah, I
Um,
think that's a good point. Let's cover that. Yeah,
so okay, depending on the user location, we have to figure out the say radius. I mean, to restaurants in certain radius from the location. Okay, okay. Okay, let's start with this assumptions and let's start with this much of. Let's talk about a little bit about the non-functional aspects. So maybe what kind of scale are we looking for?
Now we can say 1 million orders per day.
1 million orders per day. I will put an assumption here, maybe that orders are mostly coming in lunchtime and dinner time.
Okay.
So maybe 11:30 to 3 um, should be a good enough assumption, I guess.
Yeah, yeah, that's a good assumption. Yes.
11:30 a.m. to 3 p.m. and then and say uh, around 8 to 10:30 is the last order that
Yeah,
we would fulfill, right? So
yeah,
now, so that gives me, so I'll make it 3:30 just to ensure that we are taking whole hours. So this is what this is like 4 hours, right? 4 hours, and then this is like another. Say I'll make it 8 p.m. to 11 p.m. There's another 3 hours. So 7 hours of total 7 hours of working, right?
yeah.
So total 7 hours and 1 million orders. Okay, fine. Um, we will have to definitely think about resiliency and like latency and stuff like that, right?
Correct.
Fault
Yeah,
tolerance. Okay. And one more thing. This scale, this 1 million orders, is it like, because food ordering is typically very localized, right?
correct.
Is it over all over India that I can consider?
Yeah,
Because the
you
reason
can.
I'm thinking of, like, if I later need to shard my systems, then I could basically concentrate on like, then the load reduces, right? If it is complete India.
Yeah. Actually, let's consider as a single country. I like how he has made a section called assumptions, and he's putting all of the assumptions that he has been doing in that section. That's a good way of just cutting down scope, saying that, hey, this is what I'm assuming. And I can come back and get rid of the assumption at a later point in time.
Sharding is required, then maybe on zone basis I can have separate systems and
Yeah,
then localize the order, right?
yeah,
Okay, yeah, we have spent quite some time on this, so let's take these are the requirements and think about it. So the first thing that I can think of is that it will be a eventing system, event-based system completely asynchronous, right?
yeah.
Okay. Um, the integration of OMS, can I assume that that particular integration is all taken care of in the sense that the OMS probably would notify the agent which is there. I guess I don't know how exactly it can be
Yeah,
done,
yeah.
but
I
I
think that's a um reasonable assumption. Yes.
okay. So I'm considering on their OMS system, there will be a every, or say smaller restaurants would not have a OMS per se, but the POS system what they have, right?
Yeah.
That kind of has an agent running in and that interacts with their system.
Okay. Yeah.
So okay, and our system talks to that agent.
Yeah.
Okay,
Yeah. Let's focus
so
on how your system talks to that agent, as in
sure,
what would you
got
expose?
it, got it. Yeah. So. Um, So let me talk about the entities that I am thinking of. One is user, and user would have, say, name, email, phone number, and multiple addresses. And then, I mean, we can think of primary address and secondary address, default address and non-default addresses and stuff, right? So let's consider this model for the time being. We'll modify accordingly. Now, from the cataloging side, what I need is restaurant. So again, name, then basically need the address, and this would have location information, location, and okay, and then this restaurant would have so now I have dishes as one entity, let's say, which would have name and description. We need a mapping between a restaurant and dishes. Yeah, the reason, I mean, we could have a separate entity as dishes. The reason I'm thinking of in this way, let's say, for example, Hyderabadi biryani, right? I mean,
Yeah.
they could be like served by multiple restaurants, right? So I could see a N cross M relationship over here. We could also think about that. Okay, we will not normalize it in that way, but we'll all the dishes for a particular restaurants are unique, and we'll give them a unique name. That is also a fair, I guess, a fair.
A pro tip here. The time to think about new features is during the requirements phase, like the first, 10, 15 minutes. Uh, After that, when you have started designing the system or writing the entities, it's best that you do not introduce new features. Because if you think of new features and the interviewer might say, yeah, you could include it, but it's just gonna puzzle you and it will break your line of thought. So don't do this. So that here's another feature I thought, but I'm just gonna put that in out of scope now. Best to not think of any features, stick to the requirements because by the time when you start designing the entities, your requirements are locked.
So this is in the catalog side. This is on the user side. So, okay. Uh, what else? I need some sort of uh, some sort of menu can be done from here. So when the user comes in, he selects the dishes and then puts it into cart. Say a cart. Assumption is that all dishes are from same restaurant.
Yep.
Okay, this is an assumption. Otherwise, we'll have to break that cart into multiple orders and give it to multiple people. But
Yeah.
for today's sake, let's consider that it will all go
Correct.
into one restaurant.
Yeah.
Fair assumption, right?
Yeah. That's fair assumption.
Okay. So then, when the cart is checked out, it gets converted. The list gets converted into an order. So order would have, say, um, order would have some ID, user ID, restaurant ID. ID 4 is say um, uh, what else? Restaurant ID. I'm not taking care of the payments part. Do I need to talk about that as well?
No, we can, yeah,
No, we can just
leave that
have
part.
a state like
Yeah.
payments done or something, right?
Yeah.
Okay. Then there would be a order item table. Uh, So order item would be, say, uh, dish ID. Then dish ID, it could be number of plates or portions. Number three is then uh, your your order ID. I'm just normalizing it. We'll see if the normalization makes sense after some time.
Okay.
I'm trying to figure out the normalized data model. Okay,
Okay.
so once the order is done, I need some information about my delivery boys. A fulfillment system, let's say. So in fulfillment system, the first would be yeah, again, not much, some name, uh, some ratings or something. We'll see. We are just to see show something over there, and then I need a delivery boy to say pin code mapping, or say, should we consider pin code or should we consider lat long? Because pin code mapping could be that the person is just assigned to one pin code, and then the next pin code, which is say 500 meters apart,
Yeah.
but it's a complete
So,
different pin code. So
correct.
what could
So,
be?
for now, for simplicity, let's just do pin code because we need to find the current location and whatnot. So, yes, current pin code is
Oh, well,
fine.
okay. So
We'll say some pin code
uh,
list of pin codes that he can deliver to and or he can pick up from. So that's sort of thing.
yeah, can I assume that those two lists would be same,
Yeah,
or
yeah,
if the
it's
pin
same. Yeah,
codes
it would
and
be same. Correct. Yep.
right? Okay, so I just put it down that pickup location, pin codes, and delivery pin codes are same, right? Okay. Mm, and then uh, this would be a transactional table. If it's not working, then probably I would delete the entries from this table, maybe
If
every day.
is let's say they will have work hours, right?
Mhm.
So you you'd need to know whether they're working or not.
Yes, that's a good. Uh, no, the thing is, like, I'm thinking that the delivery boy, can he be assigned to a different pin codes at a later point in time? Maybe today
Um,
he's serving some pin code,
yeah,
tomorrow
probably, but
he's
let's
not.
let's let's not keep that out of scope for this interview.
Okay, okay. So let's not touch over here. Let's consider that. How should I name it? Delivery boy. Um, roster, something like that. I don't know if roster spelling is. So uh, attendance system, maybe, right?
Yeah.
So which would have boy ID, and then whether he's working today or not, right? And the hours, maybe. Uh, Hours could be like um, maybe a start hour or end hour, or start hour and end hour. But then that would mean that there, I mean, there could be start hour or
Now, since this is a really large problem, then it would take time to design the entities. So make sure you remember that you do not need to write all the metadata. It's fine to speak through it and say, here's the metadata that we will store, and not go into the details of it. Everybody understands that there are going to be a ton of metadata for such a system. You really don't have to pinpoint each and every one of them.
delivery thing, and what I need is some sort of now uh, the okay on the OMS side, so fulfillment side. This is fine. Just give me a moment. Let me think about it a bit.
Yeah.
Mm, so, something. Definitely the status part, the finite state machine that would run for both the systems, that has to be captured somewhere. That modeling has to be done. Okay, so yeah, let's talk about that modeling after some time. Uh, uh, just for the sake of time, let me think about the services that I would have, right?
Yeah.
Uh, okay, let's shift to maybe broader dive. So maybe start off with the API gateway,
So
and then
you'll come back to the actual data modeling, right? Or
we'll come back for the FSM. We'll come back. We'll make the changes when whatever is required. I am just thinking of like have the overall picture of the how the system would look like, and then we'll change the modeling as and when required,
yeah,
right?
yeah,
I'll talk about the APIs once I have the idea what are the systems that will be there, because few of the systems would be transactional and few of the systems would be like event based, right? So I'm just
yeah,
trying to understand what is what, right?
yeah.
Okay, so the first thing, I think this is the uh, IAM maybe, which is taken care of. Then I probably have a OMS system and a fulfillment system, let's say. Okay, I have say a listing versus catalog. Okay, um, fulfillment would take care of the delivery. OMS would take care of the order.
Now you see, John has put a box called IAM. IAM stands for Identity Access Management. In most system design problems, you would have some sort of identity where the user needs to log in with their Google account ID or some other ID. Uh, that is kind of orthogonal to the rest of the system design, and it's a pretty complicated aspect, authentication and identity management. It's best to just call it a separate box called as IAM and put it there. It's unlikely that the interviewer would be interested in that part of it, of the system. They would be looking into the actual business logic which you would be designing.
We may not get foreign key relationships and all
Yeah.
that I
Okay.
designed for you, right? Um, okay, I would definitely use some sort of a message bus in the system. Messaging. Okay, so slash user management. Okay, let's say we have mobile app, and then we have the OMS agents over here. And then we have web app or something. So this side, for the sake of simplicity, this side we will say that okay, we are only working with HTTP,
Yeah.
right? So this interface is HTTP interface or REST interface maybe.
Yeah.
Okay, and this side could be messaging, whatever, right?
Yeah.
Not directly messaging, but maybe they will be talking to other individual systems, and the messaging will happen from the individual systems to that system, right?
Yeah.
So OMS would talk to messaging, fulfillment would talk to messaging, listing would definitely talk to messaging. No, listing doesn't need to be message driven. Uh, they are mostly static information. Mm. Okay, let's go by this particular design for the timing. We'll come to it and change it accordingly.
Okay.
Uh, and let's say each one of them are taking care of um their own data, and they have their own databases, right?
Yeah. Yeah.
Uh, okay, so now let's uh, work on the user journey. So number one, so user comes to the app, searches for a dish,
Yeah. We can we
gets
instead of search, we can just simplify it to say it goes to a restaurant. Like there's a list of restaurants, so there's no search in the system.
okay. So then when the user comes up,
And they see a list
then
of restaurants.
so maybe it does a get query to restaurants, and
Yeah.
like mm, mm, implicitly somewhere, I mean, maybe we'll just give the pin code,
Correct.
right?
Yeah.
Some pin code, right? And then uh, problem is I need some mapping in which it says that one pin code is mapped to some other pin code, and this pin code is serviceable from the other pin code. It's kind of like, what um,
Yeah.
uh,
You
what I'm it's kind
you
of a
could.
pin code graph, right? One pin code
Yeah.
is serviceable, a serviceability graph sort of,
Yeah.
right?
Yeah.
So that would be part of the SIG fulfillment system. So, so graph. So essentially, one pin code.
You could we could further simplify this. We can say that the restaurant tells us that what is the pin code they are gonna serve.
Okay, and that may change every day.
That might change every day, but yeah, it's something that they when they start say that hey, this is the pin code we are serving, and of course you'll have some limits, but
That's correct. Abhi. The only thing I'm thinking of that it needs an inverted index, right? Because
yes,
when I'm searching,
correct,
I kind of need a pin code, and then I need to figure out all the restaurants
that's true.
that. So maybe what like the restaurant may give us the pin codes that it is servicing.
Correct. Hmm.
What we need to do is we need to take as a pre-processing, we may have to basically go
Yes.
and create this index, right?
Yeah. Yeah.
Uh, some sort of pin code to pin code mapping.
Yeah.
Right? And again, I will just keep it and let's say, um, and pin code to pin code mapping, and then I need a pin code to restaurant mapping. Right?
Mm.
Okay, okay.
Now, inverted index is a good concept to have, especially when you're designing systems like these. Each restaurants would mention the pin codes they are serviceable in. Same thing for delivery persons. Each delivery person would be assigned to a set of pin codes. But as a system, we would need to know for a pin code, what are the restaurants that the user can see? And for that pin code, what are the delivery agents that we can assign to? And hence, we need to invert the relationship from restaurants to pin code to pin code to restaurants. And that's what he is doing.
All pin codes serviceable. Right? Then get me all restaurants on these pin codes.
Yeah,
Right? And then pagination on top of it.
yeah,
Right? And
mm,
then when I click on the pin code on a particular restaurant, what I
mm,
can think of is slash some ID, and then get me the dishes.
yeah,
Right? So
yeah,
this goes and looks into that dishes to restaurant mapping table
yeah,
and figures out that okay, what are the dishes? Say I left join to right gets the dishes. Now, what the user does is user adds things into cart, right?
yeah,
So essentially, it is it is creating the cart first, and
yeah,
then it is updating the cart.
yeah,
For the simplicity, we'll consider that will always one particular user will always have one cart associated to it.
yeah,
So from the standpoint of REST, what I can think of that I'll always update a cart which is existing,
correct.
right? Just
Yes.
for simplicity. So I will
Yep.
say put cart and some cart ID uh, because I will know my system will know what is the ID related to my card, or it could be passed on as a uh, uh, I mean not exactly card ID. It is not mapping to a particular card ID, or say I'll say for the time being user ID, right?
Yeah,
And consider
yeah,
that each user has got one card associated with them,
yeah,
right? And then here I will pass on this information restaurant uh, comma dish ID.
while I really like the format that John is following, like where he write the APIs and then he's writing about like few lines about the APIs, that's good in theory. In practice, you would never have that much of time. And I would ask you to refrain from doing so. And the more you practice, the more you would can do this in your mind and you would not have to write those down because speaking is much easier than writing things down. And do not expect to get write everything properly, like forget the numbering, it's fine. This is an interview and you need to be fast. Remember, you all you have is around 45 minutes, out of which 5 minutes the interviewers use for questions or for your questions.
Slash user ID slash checkout, right? This would take care of my payments and stuff like that. So what happens? So okay, let's talk about. I spoke about the pin code and how the restaurant will be pulled in. The dishes pulling in the dishes will be easy because I already have the mapping. Cart is also fine. So in the cart, what will happen is the system would talk to the order management system.
Yeah,
right? Um, and the restaurant ID and the dish ID, these all information needs to be there. So maybe when a restaurant is added to the system,
Yeah.
or a dish is added to the system, the order management system also keeps a copy of it
Okay.
in the format that it requires, right?
Yeah. Yeah.
Typically, what we do in, say, event sourcing or event-driven architectures, right?
Yeah. So John talks about event sourcing architecture. What is event sourcing? So in sourcing architecture, the application sends an event notifying that some state has changed and also put what the state change has been into that event. So, and the listener needs to store all the list of events. And when they start applying the list of events one by one, so it has a log of changes, it will come to the same final state as the original system. So instead of the original system just giving the final state, the original system spits out all the individual changes that led to the final state. That's the event sourcing architecture. And in asynchronous systems like these, the event sourcing architecture is very, very important. Make sure you look at Martin Fowler's videos, which are linked in the description about event sourcing architecture. Yeah.
Typically, everybody should have their own data model.
Mm.
I mean, though it might be copies, but still it can have
Yep.
a data model of its own, right? Now, when it goes to a checkout, the OMS system does a, I mean, directly goes to the OMS system. OMS system may can talk to the payment system for the payment related stuff. I'm not going into that right now,
Yeah, let's
considering
not
that
go
that
into
is
that.
taken care of,
Yeah,
and checkout is either successful or say failed, right?
yeah,
Some
yeah,
for some reason. Um, okay, once this is done, what the OMS system would do is it would basically go and uh, it would basically go and um, okay. Now, one thing that I didn't spoke about is how will I know about what dishes are available, right? So maybe at the starting of the day, right, the when the when the OMS system of the restaurant is switched on or something like
yeah.
that. So every day morning, depending on what is serviceable, this the OMS agent could send out a request to us, and
Yeah.
that can be tracked in the listing or catalog,
Okay.
right?
Yeah.
And
So you'll
depending on
expose
that,
an like a webhook.
a kind of webhook, yes,
Yeah.
right?
Yeah.
Which would basically come to this system,
Yeah. Okay.
right? That's how these data models will be. I mean, the
Yeah.
listing data
Got it.
model would be updated, and all this will be taken care of. Okay, fine. So now the OMS uh, gets the order, creates an order entity, um, so sends out a notification, sends out a notification to uh, the POS system for the order, or let me call it restaurant agent. Now, I need to think about how will this delivery happen, because they cannot be over. Um, they cannot be. Uh, okay, so what I was thinking was how will the order management system notify this particular agent that
Mm.
some order has come. So for the simplicity, what I would do is I will do it as a poll based system. Okay.
Mm.
For just for the simplicity, the OMS agent can poll every 30 seconds. Let's say polls every 30 seconds and says if there is any active order for me.
I see.
Okay.
Mm.
Otherwise, otherwise I will have to keep track of all the, I mean, this OMS agent has to basically serve some APIs. It just cannot be a client, right? We'll have to call their APIs then.
Okay.
You're getting my point, right? I mean, like,
Mm.
if this is a client, then it can pull things up. If this is not a client,
Mm.
uh, then
Any reason why you are
it
going for a pull-based approach and not a push-based approach?
so in a push-based approach, I need to know about the endpoints of all the OMS agents, and I need to basically keep track of it. Um, and each agent has to then expose some REST APIs, considering I'll only use REST. I'm not
Mm.
going into details about WebSockets and all.
Okay.
WebSockets is a different beast altogether,
Yeah,
right?
that's different. Yeah. Mm. Yeah. Okay. Okay. Let's go ahead with poll.
Okay, let's say it is polling every 30 seconds. So now, for in the next poll, this guy will basically go get an get an get a new order in which it will say that okay, this is a new order, right? And
Yeah.
then internally it would internally, it would place the order in its system and send out REST API call to the OMS, right? Uh,
Yeah.
when the order is picked up for, I mean, this could be that this could be order confirmed,
Yeah.
and when the order is in kitchen, then we can say that order is getting prepared.
Yeah. But how do you know that? You don't know that, right? Because
No, I will
that's the
tell you. Yeah.
okay.
Now, the whole idea is that the agent talks to this API gateway over HTTP, right? That was my assumption earlier. So the
Mm.
agent could actually say that, okay, it is getting prepared. And from that, we can convert it into a message and push it into our messaging system, and the
So
OMS could get it from.
who is OMS talking to? As in where it goes to API gateway, and from there OMS is talking to which system? Is it like there should be a system here like which
Yeah,
understands it? Mm.
see, absolutely. I mean, that's a good point. That's a good point. Let's consider. Okay, just for the sake of assumption, let's consider the gateway talks to OMS over HTTP.
Okay.
Okay,
Yeah.
and it also talks to listing over HTTP. I mean, gateway doesn't do anything,
Yeah.
right? It just
Yeah.
depending on the endpoint, it just goes and routes the thing into a
Yeah.
particular system,
Okay.
right?
Mm.
So the restaurant has to interact with our OMS system. The
Yeah.
restaurant has to interact with the restaurant. Does it need to interact with the listing? Yes, because when the system sends out the um, dishes and all information, that has to go into our listing system. Okay,
Yeah.
fine.
Okay.
Um, so
Uh,
essentially, it is still event driven, but over HTTP on this
that's
side.
that's that's yeah.
With
So your
with the
order has reached the so you put a message into messaging queue. So what happens after that?
So the message has been put in. The what we can do is once the order has been placed in kitchen for the order getting prepared, this message, the OMS
Mm.
could send out a messaging to the fulfillment system, right?
Yeah.
That okay, now start a counter, and okay, the kitchen says that okay, this it will take 30 minutes, right?
Yeah.
So you'll have to basically provision a delivery boy within that 30 minutes, and the
Yeah.
delivery boy should reach that particular restaurant within that 30 minutes, right? So
Yeah.
considering the fulfillment takes care of the location part and current location of the
Fair.
where, I mean, it basically goes and sees okay, what are the list of delivery boy that are there who can service that restaurant and the address, and then who is nearby, right?
Yeah.
Is it making sense?
Yeah. That makes sense. And
Okay,
so, how does the user get to know what's the status?
sure. I will come to that. Just give me a moment.
Hmm.
Okay. Um, just give me a moment. So the order is getting prepared. So the fulfillment gets a event, and then basically fulfillment starts up a finite state machine. Looks for the looks for the uh, delivery boy who can service it, and then it basically the delivery boy would also have a app somewhere. And once the delivery person is selected, the delivery message.
Now, there are multiple ways to skin the cat. Of course, polling is one of the ways. One of the more sophisticated ways is webhooks, very similar to how Slack webhooks work, where the OMS agent, which the restaurant is running, registers itself with the our system and tells that here is the callback. So whenever there is an order change or whenever there is a new order, just call me with this URL, and I'm going to call you back whenever there is an order change.
Simplicity, let's consider it as doing a pool-based system, right?
Mm. Yeah,
I mean, uh, just for today's year, in actual
yeah, yeah,
implementation, probably there will be a WebSocket infrastructure which
yeah,
will serve that way of delivery
yeah,
apps,
yeah,
right? And then it talks to the fulfillment system, asking for if there is any order, right? Whenever there is any order, it floats in his application, and he
yeah.
says, okay, order confirmed. That again talks over HTTP and talks to the fulfillment system, and then it basically changes the state over here, right?
I see. Yeah,
Now what we can do is from the now when the delivery person arrives over there, and then when the delivery person acknowledges that, the system starts the delivery app should start sending location information, right?
yeah,
And then location information should be on the maybe on the fulfillment side should track that location information. And what would happen is the user's app would get the state from two different places, OMS system
yeah,
and the fulfillment system, right?
yeah,
The reason being the OMS will tell what is the status of the order, in the sense, and in the sense whether it is getting prepared and things like that, and the
yeah,
fulfillment system will say what is the status of the delivery person,
yeah, yeah,
right?
yeah,
Again, for simplicity, let's consider that they are just a poll-based system,
yeah.
right?
Okay.
It is polling and trying to get that information at every certain interval, right? So the page, the status page, the order status page would be served by OMS and fulfillment, right?
Yeah,
Now, when the order, when the delivery person reaches, right? Delivery
yeah.
person reaches, then fulfillment would get a notification. Fulfillment can send a message to the OMS system that the delivery has, yeah, and then the we can have a state in the order.
I'm not really a fan of a lot of pool-based architectures. Generally, one of the ways to do this is have a notification server which listens to this main Kafka pipeline and takes a notification, pushes it to the client. And the notification server could work off Google and Apple notifications hub. So you really do not need to keep connections open. I want to
Mhm.
focus on the data side of things. Like what would be the database? How would you store the data?
See, yeah, this particular index part. Okay, let's consider Redis because it has to be
Okay, that makes sense.
fast,
Mm.
right? uh, these things, right, the attendance, the order system, and everything can be part of uh, it could be a normal RDBMS. I mean, right? Let's say
Mm,
Postgres.
mm.
I mean, personally, my is like start off with Postgres, and if it is not scaling, then look for others. I mean, that has been something that I have been following always whenever I'm doing something.
No, I'm not really fan of designing your database at the end. I feel that's something that you should design when you start off with your entities, like lock on a database. Here, John has chosen Postgres. There's nothing wrong with it. It's just that he himself is saying that there are scalability issues. And the way to understand if we will hit those scalability issues is to do the estimations. The estimations will tell us whether a single instance of Postgres is enough or not, or whether we would need to look at sharding, or what's the strategy should be.
Like this, right?
Okay. Would
Uh,
you have sharding
yes,
or
of
any
course.
scalability challenges that you need to take care?
Yes, the as I said previously, right? Sharding would be a problem because Postgres typically, I mean, unless and until we are using something like, say, Citus DB, or say Cockroach DB,
Mm,
typical Postgres does not support sharding,
mm,
and what would happen is that it is only vertically scaling that we can do.
mm,
Um, so at the very basic level, what we can start doing is that we can divide the whole system into four zones, and
mm.
four zones can be supported from four different um, four different.
I like the idea of dividing India into four zones and then sharding based of it. I would rather think of it as a multi-level sharding because the data in hyperlocal delivery apps are very local to that place they are in. So it could be that we shard it. We have first have four instances of compute and storage sitting in four different zones. Now inside these zones, we actually shard it by user ID. This is called multi-level sharding. First, the traffic goes to the correct zone, and from the in the zone, there are multiple shards which are sharded by user ID.
Identical systems,
Hmm.
right? Now, how would that happen? That might happen because what we can consider, we can do a subdomain based routing in all the cases, right? The user does
Hmm.
not need to know it. It has to be configured at some point in time, right?
I see.
uh, we could have a subdomain based routing, and there is a DNS, or there can be a DNS which is run by us,
Hmm.
which would ensure that those requests goes into that particular shard. I
Hmm.
mean, shard of the complete system, right?
Hmm. Yeah,
Now, if in each zone there is a sharding requirement after that, I mean, each zone's scale increases to such an extent that we need to shard each one of them. Then basically, I'll have to go and figure out the things that are working together, and which needs, depending on the access patterns, which needs joins together, right?
I see.
So would try to keep things on the, so at some places it could be on the restaurant based restaurant ID based sharding. It could be uh, user ID based sharding. I mean,
So that's the end of the interview. Couple of takeaways from the interview is that system design, like any other forms of programming, it needs practice. It needs a lot of practice so that you look at multiple problems, so that even if you have the knowledge, applying it in the correct way and making sure that you are fast and you are not going too deep unnecessarily um, will make you successful in a system design interview. It's very important to be aware of some of the tricks, like start with out of scope, be aggressive about it, put things in out of scope. While you're designing databases, do not add new features because the interviewer might just say yes and you'll be in a soup. Do not write too much. Speak more, but write less. Don't worry about formatting. It's fine if the formatting is not that great or if the numbering is not correct. So for this interview, I do feel John needs a lot more practice. Clearly, the way he was approaching the system design, the way he was talking about the terms, IAM, fulfillment, event sourcing, he definitely had the knowledge. It's just that he had to be more time sensitive to fit all of this in 45 minutes, which is going to be a bit tricky. Let me know what would you like me to cover next. If you want to schedule a mock interview with me, join the Telegram group below. Of course, please don't forget to like, share, and subscribe.